Hello friends, today we are going to solve a leetcode problem number 199, binary tree, right side view. If you just want to see the solution, then here it is the solution. Better if you will understand it yourself. If you are not able to understand the problem or the question, then I will explain it here. First see what's the problem is. The problem is very simple. We have given a binary tree, not a binary search tree, just a binary tree. We have to print the right side view of that particular binary tree. So in this particular example we have 1 2 3 4 4 5. The right side view will be 1 3 4 this, but it is not always the right thing. It can be like this, like we have a given tree 1, like we have a given tree 1 2 3 4. So in this case the right view will be this thing, that is 1 comma 3 comma 4. This will be our right side view. So it is not always a right thing. So basically we have to develop an algorithm so that we will able to find the right side view. So to develop an algorithm, let's see if we are able to store. We know that to find the right side view of a binary tree, we have to go to the a particular height. Then the rightmost node will be visible from the right side. Let's For the height equal to 0, the right most node which is visible will be 1. For the height for the second height, that is height equal to 1, the rightmost node will be visible is 3. For the height equal to 2, the rightmost node visible will be equal to 4. So if we are able to store each and every node of a particular height into a binary tree, and in a vector, and we will then print the rightmost node value into a resultant vector, our resultant vector. So basically our algorithm will be based on this principle. So in the solution, I have made a vector itr which will store each and every node of a particular height into this vector, and we will find the rightmost value in this vector and store the value of that node into our resultant vector. This is what we are going to do in the algorithm. So this is our base case where our the root we will where we will store the root in itr, and if root is not null, then we will store into itr, and the value will be stored into the result. Basically we are going to store into the vector only those nodes whose values is not null. Basically we can see that in this height equal to 3, the right node, the height equal to 2, the right node of the 2 is null. Then we are not going to store it. We are going only to store it the 4, which is not null value. So basically we have to see that if it is null, then we are not going to store it. This is same we are going to do with intermediary nodes. Let's see, for height not equal to 0, we are how we are iterating to this vector. We know that the root, the left and right child of each and every node will be in the next lower height of the next lower height. So uh, so we know that if so to move to this v4, we will iterate each and every node of this vector and store, see that if its left hand child are null or not. If they are not null, then we are going to store it into a temp vector, and temp vector if these are not null, and then we are replacing the temp with itr. And where this will where this our while loop will end, when we will know that in a place will come when each and every node will be null. So in that particular case, our itr vector will be null. If it is null, then we are going to stop it, and for each and every height we are going to store the rightmost tree value, the rightmost node value into a resultant vector, and we are going to print this. So this is the basic algorithm. I hope you understand. Thank you. Bye.